Campbell Benzinato, he was on there, he was waiting for me. While the punk rockers and the moon stompers, they're out on the corners where they're sparing for change. I started thinking, you know I started drinking. I don't really remember too much of that day. Something struck me funny when we ran out of money. Where do you go now when you're only 15? With the music execution and the talk of revolution, pretending. But when it got wrong, give on the boat, the roots are radicals. Give on the boat, you now I'm a radical. Give on the boat, the roots are ringing on my stereo. The radio was playing Desmond Deco was singing on the 43 bus as we climb up the hill. Nothing ain't coming with the rate gauge rolling, and we all come from one little acid.
Okay, welcome. It's election day, so I'm wearing street clothes, and you're not here, so I decided to make a video so I could do some math to keep myself entertained on this Tuesday. In any event, we are talking now about simplifying radicals. In other words, roots, right? The radical symbol, usually we talk about square roots, but this year in Algebra 2 we'll also talk about other roots, like cube roots, somewhere down the road, okay? But a review from Algebra 1, I know I say that a lot because a lot of the skills we do in Algebra 2 are Algebra 1 skills. You just review them and take them one step further. This is an example. This is one particular concept that you've studied quite a bit in Algebra 1 and even in geometry with the Pythagorean theorem with square rooting. You had to use that to solve with Pythagorean theorem problems. So, simplifying radicals is all about the perfect squares. You've got to be very, very familiar with perfect squares, okay? And multiples of perfect squares. Meaning not just the number 9, but also that 9 goes into 27. Not just the number 16, but that 16 goes into 48. Not just the number 36, but the 36 goes into 72. So the perfect squares and multiples of those perfect squares. All right, you've got to be very familiar with those. Okay, now, instead of just giving you boring old, all right, simplify root 20, simplify root 40, simplify root 50, simplify root 8, etc., I'm going to go a little different direction here and have you find the error in these problems. So the first line is the actual problem, and then I did something wrong, or multiple things wrong, in my work, and you've got to find that, okay? Now it's going to be hard with doing a video. I can't really call on you to show the error, but think about it. You had some time to look at this while the music was playing. That was Rancid, by the way. The band was called Rancid. They were a punk rock group from the early mid-90s. All right, they were pretty big. I saw them play at the Electric Factory back in the day. In any event, the square root of 32. All right, what did I do wrong here? Well, I started by breaking this up into the product of two radicals. That is how I teach simplifying radicals. Some teachers show these branches and tree limbs, and I focus upon splitting this up, breaking it apart into the product of two radicals, okay? And the first radical, I always write the perfect square, okay? You have to use a perfect square doing it this way. All right, well, it's going to be the easiest method. If you have 32, I used 16 and 2, so I broke it up into root 16 times root 2. Notice how I wrote the perfect square radical first, okay? Just to remind us that that whole number is going to be on the outside of the square root. Okay, the square root of 16 is 4. That's wrong. It's not root 4. This is the wrong part, okay? So it's a technicality to you, but it's a very big problem to me, okay? The square root of 16 is just the number 4, right? This is asking ourselves, what number times itself is 16? Well, 4 times 4 is 16. So this is not root 4. This should just be 4, okay? Now, root 4 is 2. The square root of 4 is 2. So from this step to this step, well, that was done correctly, but I had already messed up. This shouldn't be a root 4. This should just be a 4. So the answer is not 2 root 2. The answer is 4 root 2. 4 times root 2. We just write 4 on the outside of a radical. 4 root 2. That's the answer. Just because this number is a perfect square doesn't mean we go further. I wanted to show you this example because it is a mistake I see students make. They think the number outside the radical, oh, that's still a perfect square, we can do more. No, you can't, you're finished. Okay? If the problem were something like root 8, if we had all 1a, Root 8, well, you break it down using the square root of 4 times the square root of 2. Now the square root of 4, that you're square rooting that, you do get 2 root 2. So the answer would be 2 root 2 if the problem were root 8, totally different than root 32. All right. Next, we have a problem with subtraction. All right. A lot of problems we do involve subtraction and addition, also multiplication and division. But in this case, it's a subtraction problem. The instructions are, by the way, simplify completely. Simplify is a very ambiguous term in algebra, but with radicals it means you've got to make sure in your answer that what's underneath the radical contains no perfect square factors. I should have said that at the beginning. But your answer you've got to make sure that when you break this down, in your answer, the number under the radical contains no perfect square factors. So if we used 4 and 8, because 4 is a perfect square, 8 still would contain a perfect square of 4 that went into it. So it's always a good idea to choose the largest perfect square. Okay, like again, if you had chosen 4 and 8, if you had done it like this, you would get 2 root 8, but then what's under the 8, there's still a 4 in there. You'd have to go further. 2 times root 4 times root 2. Root 4 is 2, so we get 4 root 2. All right, a much longer process. I don't even know if you can read that, but this is what happens if you don't take out the largest perfect square. You want to use the largest perfect square. Back to problem 2. Sorry, I went off on a bit of a tangent here. Right? Back to problem 2, we have a subtraction problem. I took away 3 minus 7 and got negative 4. And then 20 minus 5 and got 15. So that's right? No, the whole thing is wrong. You can't do this. Again, this just goes to show just because something looks right in math doesn't mean that it is, right? X squared plus x to the third is not equal to x to the fifth. That seems like it should be right, but it's not. You can't add these. They're not like terms, all right? Same idea. If you're adding or subtracting radicals, you can't do that, just like you can't do this. You can't add root x plus root y is not root x plus y. Okay, you cannot add the numbers under the radical and push them underneath one square root. The only time you can add radicals, same kind of situation as if you're adding with exponents. If they have the same exponent, okay, yeah, you get 2 of them, right? 2x squareds. Well, root x plus root x, they have the same number under the radical. That is 2 root x. Okay? So it's the same idea by collecting like terms. These are not like terms. Root 20 and root 5. Not the same number underneath there. We cannot subtract those. But, so this is all garbage. Don't do that. But what we can do is we can simplify the first one. All right? 7 root 5, this is considered completely simplified, because 5 contains no perfect squares as factors. But 20 does contain a perfect square factor. Right? 4 times 5 is 20. That's why you've got to always recognize these perfect squares and multiples of those perfect squares. You've got to figure out which one of those, what's the highest one of those that goes into this number. So we just bring down the 3. If there's no operation, it's implied that it's multiplying. So 3 times, and now root 20 would be root 4 times root 5. And we'll just bring down the minus 7 root 5. What is root 4? Good, it's 2. So we have 3 times 2 times root 5, which is actually 6 root 5. All right, make sure you understand how I went from 3 root 20 to 6 root 5. You got that? I just simplified, kind of ignore the 3. Root 20 becomes 2 root 5 when you simplify. And 3 times 2 is 6. 6 root 5 minus 7 root 5. Now they're like terms. They both have a root 5. It's like 6x minus 7x is negative 1x. Well, 6 root 5 minus 7 root 5 is negative 1 root 5, or just negative root 5, and that's the answer. Okay? Now, number 3, root 72. Well, as I alluded to earlier, when you have more than one perfect square that goes into this number, you always want to look for the largest perfect square. It'll make your life a lot easier in the long run. Right here, if you use 16 and 2, the answer is just 4 root 2. Whereas if you use 4 and 8, you've got to go a more roundabout way. And the answer is not 2 root 8, right? This is not the answer is not 2 root 8. The answer is 4 root 2. But we've got to now break down the root 8 even further. That's a pain. Okay, I highly recommend you look for the largest perfect square. So in 72, 36 is the largest perfect square, but 4 and 9 both also go into 72, all right? But we're finding the error. So this is not necessarily an error. It's not the best way to approach the problem, in my opinion. My thought would be root 36 times root 2 to start. But this is not incorrect. This is not incorrect even in the answer, but it says simplify completely, all right? And again, this is not considered simplified completely because 18 contains a perfect square of 9 as a factor. So from here, I would erase the box here. So there's nothing done wrong. It's just not simplified completely. We've got to keep going. Had we chosen 36 and 2, it would have been a more straightforward approach. But we've already gone this way. We might as well finish what we started. So you break down 18 into, or root 18 into root 9, root 2. We have 2 times root 9 is 3. So we have 2 times 3 root 2. We have 6 root 2 as the answer. Right? That's completely simplified. 6 root 2. And once again, the easiest way to do this would have been to go root 36 times root 2, and the square root of 36 is 6, and the answer is 6 root 2. That's a whole lot faster had we chosen to use the largest perfect square, 36, and not 4 and not 9, right? Not 9 times 8, but 36 times 2 is the most direct. Either way, the answer is 6 root 2. All right? So just a couple problems to review. So just to review the review. I went over how to simplify a basic square root like root 32, like root 8, like root 20, like root 18, like root 72. All right? And I also mentioned subtraction. This also works for addition. Be careful again. You do not subtract 3 minus 7 and 20 minus 5. No, just because that seems right. You've got to, the only way these are going to be able to be combined is if they have the same number under the radical, which they eventually do. Right? This is really 6 root 5. 6 root 5 minus 7 root 5 is negative 1 root 5. All right? When we're multiplying radicals, it's a different story, and we can get into that in class. Multiplying radicals is actually, I think, a little bit easier. Right? But just like we can multiply with exponents, we can multiply with radicals. You can multiply anything with radicals, but you can only add or subtract if they have the same exact number under the radical, like root 5. 6 root 5 minus 7 root 5, negative 1 root 5. Right? You would never add or subtract the numbers under the radical. Never. 5 minus 5, no. Do not do that. All right?